So I'm recording now. Today's lesson is on graphing absolute value functions. Graphing absolute value functions. And we remember when we went over Desmos at the end of the class. Recently, we played around with graphing these absolute value functions. We played around with them. Now we're going to actually learn how to do it ourselves. So in order to begin, we are going to plot the most simple absolute value function, which is just the absolute value of x. And in order to do that, we're going to do a t-chart here, x f of x. And I'm going to pick the points -2, -1, 0, 1, 2. And I'm picking these because I know these will work. Okay. So -2, absolute value. First off, absolute value does what to a negative number? Makes it positive. Does it do anything to a positive number? No, it just keeps it positive. All right. So absolute value of -2 is 2. Absolute value of -1 is 1. Plug in 0, it stays 0. Plug in 1, it stays 1, and same for 2. Once I have those, I can go ahead and plot my points. -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. And once I've got my points, I can go ahead and graph the line. And there you have simplest absolute value function, just f of x equals x. This is our parent function. This is the starting point of all the rest of today's activities. All the rest of today's activities start from this parent function. Okay. Any questions on how I plotted this? No, how we graphed this? Now, we're going to have to know this shape like really quickly, really easily, like the back of our hands. The idea is the vertex here, it's got a vertex that comes to a point, that's at 0, 0. From the vertex, it goes up with a slope of 1, and then same thing to the left. Okay? So, just like that. Okay, and we have to be able to recognize that shape, and we have to be able to come up with that shape pretty quickly. Now, with that said, obviously this is not the only absolute value function, so we're going to continue on the journey. So I've given you those coordinate planes on that paper very specifically because each graph that we do, you can do it on a new plot. So for this one now, I'm going to do f of x equals absolute value of x plus 3. Now, who can tell me what that plus 3 does to my graph? Isaiah?
It makes you go up 3.
Up 3. Very good. When I have something added or subtracted on the outside of these absolute value brackets here, it is called a vertical shift. It shifts it vertically, and it shifts it exactly how you think it would be when it's on the outside. If it's plus 3, it goes up 3. If it was -3, what do you think it would do? It would go down 3. Okay, but it may not be the easiest just to see that, so we're going to use the same points as we used last time. -2, -1, 0, 1, 2. And we're going to plug them into our function and see what we get. So the absolute value of -2 is 2, plus 3 is 5. Absolute value of -1 is 1, plus 3 is 4. Absolute value of 0 is 0, plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. So I filled in the t-chart, and now that I've got my points, I go ahead and graph them. So I have -2, 5. -1, 4. 0, 3. 1, God bless you, 4, and 2, 5. Once I've got those points, I'll go ahead and graph the lines. And with that, we can pretty clearly see that I've got the exact same function, just shifted up 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. Every point is shifted up 3. You guys see that? Cool. Good. Chromebooks can be away, guys. That's the last we'll use the Chromebook, so you can put them in your backpacks. So we have a vertical shift of +3. Cool, so now we know about vertical shift. When it's on the outside here, we do exactly what we think we would do with a vertical shift, up 3. Cool, got it. Any questions? Okay, let's move forward. The next one, we'll do f of x equals absolute value of x plus 3 inside of the absolute value bracket. Now, who can tell me what this is going to do? Yes?
Is it going to shift it on the x-axis?
Yes, it's going to horizontally shift it. How is it going to horizontally shift it? Question. Yes, sir?
To the right.
To the right is what we would think. Most people would think. It's the opposite. To the left, to the left. When it's plus on the inside, to the left. Oh, okay. Nice. Right? Okay, so it's a horizontal shift when it's on the inside, but it does the opposite of what you think it would do. On the outside with a vertical shift, it does just what you think it would do. But on the inside with the horizontal shift, it does the opposite. So if it's plus, it goes to the left, and if it's minus, it goes to the right. Good. So we know we're horizontally shifting 3 to the left here, but we may not be able to just see that. So I'm going to pick points, and I know that these points will work, -5 to -1. I know these will work because I've done this before, so I know that these will work. Okay? That's why I'm picking these points. Okay, -5 to -1. And I plug these in. -5 plus 3 is -2. Absolute value of -2 is 2. -4 plus 3 is -1. Absolute value of -1 is 1. -3 plus 3 is 0. -2 plus 3 is 1. And -1 plus 3 is 2. Once I filled out my t-chart, I can go ahead and plot my points. -5 is 2. -4 is 1. -3 is 0. -2 is 1. And -1 is 2. Once I've got the points, I go ahead and graph the lines. And we can pretty clearly see that our graph is shifted 3 to the left. You see? You see that? This vertex here shifted 3 to the left. Each point, 3 to the left. Cool. So it did exactly what we thought it would do. Okay. All right. Now, you got any questions on that? Remember, on the outside, it does what you think. On the inside, it does the opposite. Okay? All right. Next, what about if I have both at the same time? Absolute value of x minus 2 plus 3. Okay, now I'm doing two things at the same time. I know what the deal is, so I don't want to actually go ahead and do all these points now in my t-chart. I just want to apply my understanding, which is that this right here is my vertical shift, and what's that going to do to the function? Up 3, right? So it's going to take my parent function and shift it up 3, and this is going to do what? 2 to the
Right.
2 to the right. It's right because it's negative. So it goes 2 to the right. So I'm going to take each point. I'll start with this one here. I'll go 2 to the right and up. 1, 2, 3. This point, 2 to the right, up. 1, 2, 3. 2 to the right, up. 1, 2, 3. 2 to the right, up. 1, 2, 3. And 2 to the right, up. 1, 2, 3. Once I have that, I can go ahead and plot my graph. Okay? So I started with the parent function rather than filling out the t-chart. Rather than filling out the t-chart class, I just applied my transformations. You see? So that's pretty cool. And if I kind of color code this here for a second, I take this point, say I take my vertex, well I go 2 to the right, that's my 2 to the right here, 1, 2, and then I go 1, 2, 3 up. You guys see that? Pretty cool, right? So we're transforming each point like that. Any questions about this? No? You guys think you're ready to do one on your own? Okay. All right, so let's go ahead and do one on our own. F of x equals the absolute value of x plus 1 minus 3. So go ahead and do this one on your own now. And it's easy for now, it's easiest if you start with the parent function, that absolute value of x, start with that, plot that first, and then go ahead and apply your transformations. This is just for now, while we're learning. Okay. What are my transformations? This negative 3 on the outside, what does it do? 3 down, and this positive 1, 1 to the left, right? So I take each point, I go down 3, 1 to the left. 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 And once I have that, go ahead and plot the lines. Cool? Got this? Yeah? All right. So, good job. Now, let's kick it up a notch, guys. Let's kick it up a notch. Let's add a new element to it. Okay, so we got our shifts, our vertical and our horizontal shifts. Well, there's another element to it, and that's what we'll explore now. F of x equals 2 times the absolute value of x. Okay. You might remember this. It was like A when I was playing with it. It would like change it. It was like the flapping bird, remember? Okay. But we may not specifically understand exactly what's going on. So let's go ahead and plot some points on this one to be able to figure it out. I plug in -2. Absolute value of -2 is 2. 2 times 2 is 4. Absolute value of -1 is 1. Times 2 is 2. Absolute value of 0 is 0. Times 2 is 0. Absolute value of 1 is 1. Times 2 is 2. 2 times 2 is 4. Okay, just want to make sure I'm recording. Good. All right, I go ahead and plot my points. -2, 4. -1, 2. 0, 0. 1, 2. And 2, 4. All right. So, look at that. What happened to my lines, class? Like this. But if we just look at this side here, what's the difference between the black line and the red line? The slope. What's the yes, color, good job. What's the slope of the red line? 2. Look at this, guys. Whoa, pay attention. This number A is the slope. It affects the slope. Okay? It affects the slope. Very good. Very good. So usually there was no number, so it's just 1, and my slope is just 1. But now that it's 2, the slope is 2. You guys got that? Okay. Can I delete that? Is that okay? Okay. Next one. F of x equals -2 absolute value of x. If it's negative, what happens to the graph? It reflects across the x-axis. Okay? So what is this again? What is this? Slope. So my slope is what? -2. That's my slope. Okay. So let's plug in some points and just see what happens. If I plug in -2, absolute value of -2 is 2. 2 times -2 is -4. Absolute value of -1 is 1. -2 times 1 is -2. -2 times 0 is 0. -2 times 1 is 1. -2 times 2. I'm sorry, is -1. -2 times 2 is -4. Sorry. Guys, I'm doing my math wrong right now. Sorry. My mind was in 12 different places at that moment. I plug in 1. What's 1 times -2, class? -2. I plug in 2. What's -2 times 2? -4. Okay. So I plot my points: -2, -4, -1, -2, 0, 0, 1, -2, and 2, -4. I go ahead and plot my lines. Bam. See? Okay. So not only did my slope change to -2, right? I'm not going over 1 and up 1 anymore. I'm going over 1 and down 2. You see? Over 1, down 2, over 1, down 2, over 1, down 2. You see? Okay? So it flipped and the slope changed. Okay, you guys got that? All right. Now we are ready for the big show, the main event. Okay? So let's move into the main event. Now the main event is this form here. You guys may remember this from when we played around on Desmos. A times the absolute value of x minus h plus k. So this, God bless you, is our general form of an absolute value function. Okay? I'm going to write it again here. You guys don't need to write it twice. First off, let's talk about what we know. This k, what does that do to our function? It's a vertical shift. What does the h do? Horizontal shift. And what is the a? Slope. Okay. But let me ask you something. If I take my vertex and shift it over 2 and up 3, where's my vertex? 2, 3, right? So h and k aren't just horizontal shift and vertical shift. It's the location of my vertex is at hk. So that's a very important thing. And the slope is just a. The slope of my line is a. With these two components, you can graph any of these functions. All right? So we are now done with the old way. You just use that to learn. You're now going to learn the new way and the way you will use to graph all these functions in a very simple process. The process is this. First you ask, where is the vertex? And then plot it. And then you ask, where is the slope? Okay? From those two things, you can do the absolute value function. So let's try one. Let's say f of x equals 2 times the absolute value of x minus 1 plus 2. I'm sorry. Let's do minus 3. First, where's the vertex? 1, -3. Why didn't you say -1?
Because it's an absolute value of -1, so it's just positive.
It's because, look, I'm not saying x plus h here. I'm saying x minus h. You see? So h is actually 1. Remember, inside of the absolute value, you do the opposite of what you think, right? And if it's negative, you go to the right. And if it's negative, then h is positive. Does that make sense to you guys? Mm-hmm. But k, it stays exactly how it looks. Okay? Does that make sense? Yep. Any questions on that? So there's my vertex at 1, -3, bam. And what's my slope? 2. So I've got my vertex, and I go over 1, up 2. Over 1, up 2. I've got my vertex, I go over 1, up 2, over 1 up 2. I'm sorry. Oh, I messed this point up. Once I've got that, I can go ahead and plot my function quite easily. You guys see how we did that? Did I even need the parent function? No, I didn't even need the parent function. All I had to do was ask, where's the vertex and what's the slope, and I'm done. Oh, see how excited I get about math, guys? All right, so all I have to do is find where's the vertex, what is the slope, and I'm good. All right, you guys want to try one on your own now? Okay. So you guys are going to do f of x equals 3 times the absolute value of x plus 2 minus 4. Remember, you ask where's the vertex, what's the slope, and you go from there. Okay. Where is the vertex? -2. Very good. -4. So I go ahead and plot that. -2, -4. And what's the slope? 3. Over 1 up 3. Over 1 up 3. Over 1 up 3. Over 1 up 3. Just like that. And you can see what was originally looking like a whole lot of things that you had to remember actually becomes a very simple process. So we understood all the individual components, and then we put them all together into one simple process. Okay? We don't have to figure out points in a t-chart. We don't have to transform the parent function. We just ask, where's the vertex? What's the slope? Bam, we're done. Got it? Okay. Any questions? Good? All right. All right. So now there's another component to it. It's actually something you guys should all be able to kind of understand pretty quickly. Okay. Where's the vertex of this one? -2, 1. And what's the slope? 2 over 3, right? So the only difference here is the slope is a fraction. So it's -2, 1 is my vertex. And it's rise over run, so I go up 2 over 3. Up 2 over 3. Up 2 over 3, and up 2, I don't have enough room, but it would probably be somewhere like there. Any questions on that? Find the vertex, find the slope, you're good. All right, last piece of the puzzle. Last piece of the puzzle. Can I clear this out? Okay, you guys are rocking out right now. I'm so appreciating it. All right, last piece of the puzzle. F of x equals the absolute value of 4/5 x minus 2 plus 3. You look at that and you say, what? It looks completely different, and you're right. It's not in the form that we've been given here, so something's got to change. We've got to get it into that form if we want to use it, right? Well, here's a question. How do we get into that form? What do we do with this 4/5? Distribute it out. We can pull it out. 4/5 absolute value of x minus 2 plus 3. I can go ahead. I'm not going to plot this one. You guys don't have to plot this one. The whole point was just to learn that tool. Okay? 4/5. If I were to, yes, sir?
You literally just pull it out.
Yeah, you pull it out, and there's one caveat, and I'll get to that in a second. The vertex is where?
2.
2, 3. Good job. And the slope is 4/5. You see? Just pull it out. Now, all your problems in your homework, I'm fairly certain, unless I missed one, are exactly in this form. If the parentheses wasn't around both of them, it would change a little bit, but I'm not going to do that to you right now because it's just too many steps and it's just unnecessary right now. Okay, but you just pull that out as long as those parentheses are there. Now, one caveat. What if I have f of x equals the absolute value of negative 2 times x plus 1 plus 2? Well, wait a second. Can I just pull that negative 2 out? What does the absolute value do to a negative number?
Makes it positive.
Makes it positive. So I can't just pull it out as negative, pull it out as positive. Just like that. My vertex is at negative 1, 2, and my slope is 2. I can go ahead and plot it just like that. See? Is this clear? Any good? Any questions? All right. So with that being said, you guys have homework to do. Wow, you guys are solid. You have homework to do. Page 55, numbers 1 through 15. That is due the next time I see you, which I'm fairly certain is tomorrow. Next time I see you, that's due. And then, hey, after tomorrow, 3-day weekend, woohoo! Also, this is lesson 2.1. So tomorrow we'll do lesson 2.2. So you have to do what? Watch the videos for lesson 2.2. Is that clear? Any questions? Yes, sir. Yeah, go ahead. Listen, get started on your homework now. Do the questions. Check them out. Raise your hand if you have questions. I'm here to help you. Got it? All right, good job, class.